Hi, my name is Daniel, and today I'm going to tell you what I did during my PhD at the University of Amsterdam and Avantium. Before I explain you what I did during my PhD, I want to give you some facts about plastics. Did you know that humanity produces around 400 million tons of plastics per year? And around 99% of those plastics are based from fossil fuels like oil and gas. If you would put that in a football stadium, you could fill around 400 football stadiums from top to bottom with plastic. To help change this and make materials from renewable resources like biomass was the goal of my PhD. We wanted to make materials that utilize building blocks that we can obtain from renewable resources like glucose and make them into useful materials. One especially promising, fully bio-based material is polyisosorbate succinate, or PISA, the molecular structure of which you can see here. It contains two building blocks, isosorbate and succinic acid, and both of which you can obtain from glucose. This material has actually been known for decades already, but until now it was impossible to obtain long molecular chains, which are required for actual applications in the real world. And this is because of the low reactivity of isosorbate in chemical reactions. Because if molecular chains are too short in a plastic material, the material will be very brittle and pretty much useless. This was the actual goal of my PhD, to overcome the low reactivity of interesting building blocks like this, to make fully bio-based materials that can replace fossil-based materials in the future. This way we were able for the first time to make interesting objects out of this material. This is, for example, how you get it out of a chemical reactor. It's just pellets. These are called tensile bars. You can determine the mechanical properties of the material. And this is a box that we made by 3D printing. If you follow us, you might have actually already heard about this. If you already know more about chemistry, you might have actually realized that PISA is a polyester, which you can see here. This enables the closed-loop plastic economy, as it is chemically recyclable. This is only one story on how chemistry can solve the problems that chemistry has brought us. If you want to know more, just follow us and we'll give you updates about the future.